So I would like to briefly introduce myself. My name is Heiner Linke. I'm Pro-Dean with responsibility for research at the Faculty of Engineering here at Lund University. I have a background in the field. I have a PhD in quantum semiconductor physics. I used to be the director of NanoLund until a few years ago, and have now the responsibility for research in this area. And I'm very happy to moderate this panel today. So our focus will be on materials for a sustainable future, for a sustainable European future in particular. And we have 4 distinguished members for the panel. 2 will be joining us online, and 2 are here physically. And we start with our online members. And I am very happy to welcome Joanna Drake at the European Commission since 2021, where she is in charge of coordination and implementation of strategy and policy orientation. And among many responsibilities, a focus is on the green transition, which supports member states developing and implementing reforms that contribute to achieving the goals of the Green Deal. She has had several prior roles in the Commission. Among them, she was Director for SMEs and Entrepreneurship in DG GROW between 2010 and 2015. By training, she is a Doctor of Law from the University of Malta with a postgraduate degree in Advanced European Legal Studies from the College of Europe in Belgium. So very welcome, Joanna. Thank you for joining us. Can you hear us okay?
Yes, can you hear me?
We hear you wonderfully.
Very well.
Thank you so much. So we would like to start with the first question to you. One of your focus areas as a Deputy Director General is the Green Deal. Would you mind telling us a bit about where do we stand with the Green Deal and what is the role of materials?
Thank you so much, first of all, for inviting me to this panel and to this very high-level forum, very exciting. And I'm also very grateful that you have dedicated this year's conference to promote issues related to research in advanced materials together with nanotechnologies and 2D materials. Because we know that 70% of all innovations are related to advanced materials. And of course, their widespread use in virtually all other industries is a special leverage effect. Now, just to your question, of course, alignment with the Green Deal objectives has to be the main driver of this conference. And this is because Europe has taken a binding commitment to reach the climate neutrality by 2050. And when do we start delivering? I mean, it has to be by yesterday. That's how urgent it is. This has been reinforced, the urgency and the importance for acceleration has been reinforced by the latest IPCC report. So I think the question to ask here, apart from where are we with the Green Deal, which is your question, is where do we all collectively stand on the Green Deal? First of all, I think I'm very much convinced that our common actions under the Green Deal in supporting increased sustainability and inclusiveness have provided a very strong, a very visible, a very reliable basis that has allowed us, the European Union, to navigate and to keep course through some of the most challenging of the events of the past years. Now, the Green Deal has become a truly major flagship of this Commission. I don't think anybody in the Commission today and in the Commission of tomorrow actually thinks that they can develop their policy without first thinking that is going to contribute to the Green Deal, or at least how it's not going to get into the way. But I think we need to concentrate on the how we're going to contribute. And we have been, therefore, relentlessly working with the member states, with the parliament, with the stakeholders, and we have managed in the past few years to forge several initiatives. And you've heard about them all: the climate and energy package, steering towards the climate neutrality itself, the next generation EU reacting to the crisis of COVID, the REPowerEU initiative to raise energy independence following the armed conflict in Ukraine, and recently the net zero industries and also the critical raw materials. All these are there to not only drive us together collectively towards our objectives defined in the Green Deal, but also to boost our competitiveness in the global technology sovereignty race. And despite these challenging and very disrupting events, the Green Deal is not only highly relevant, but it's very much on its way. And I'm talking here about fields that need to be supported and continuously pushed forward, such as, for instance, the research and innovation related to nanoscience and the development of new advanced materials. But these regulatory actions alone won't do much if they are not underpinned by heavy public investment commitment. So just to start from home, the reality we know best is the Horizon Europe program, and that is committing 35%, which is around 35% of 95 billion euro for climate action. Horizon Europe is also investing strongly in partnerships. That means partnerships with industry in the areas of manufacturing of batteries, clean hydrogen, chemicals, and energy-intensive industry, covering total investments of more than 9 billion euros. If we look a little bit more specifically to one section of Horizon Europe, which is Cluster 4, there is 875 million euros, which will be invested in advanced materials, and that following the Safe and Sustainable by Design initiative and to the advanced materials research as well. So I see that advanced materials as both important in the academic research field, but also very key in the industrial segment for Europe. And therefore, to sum up, the Green Deal agenda relies on what is ongoing, the ongoing initiatives, which have to remain ambitious, but also keeping very firm our look on the targets that are laying the foundations to the tangible results in the end. What does this mean? Does it mean that all is set and we can sit back and relax? I don't think so. I think what we really mean here is that we cannot actually rest on our laurels. We have to keep striving. We have to keep assuming that there will be obstacles, that we need to, bend double. That means really do double effort on commitments when it comes to especially financial support to research and innovation, both from the member states, but also from the institutions and also from the private sector, in order to help researchers, in order to help stakeholders alike, and in order to, as what Commission President Ursula von der Leyen said during her Parliament address earlier this year, that we need to keep up our commitments to make it happen and to really collectively get the results.
Wonderful, thank you so much. And I'm sure we will get back to the challenges involved in reaching the goals of the Green Deal in this session. I would like now to welcome our second panel member, Sara Mazur. Welcome, Sara.
Thank you. Can you hear me?
Yes. So Sara Mazur is the Director of Strategic Research at the Knut and Alice Wallenberg Foundation, which is one of the major finances of research and the biggest foundation for sure in Sweden. Sara has a master's degree in electrical engineering from the Royal Institute of Technology and a PhD in plasma physics. She joined the Erixon company in 1995 and was head of the Erixon research department between 2012 and 2018. Since then, she is at the Knut and Alice Wallenberg Foundation, first as a responsible for a number of the foundation's strategic initiatives, and now as a deputy executive director of the foundation. Sara, the Knut and Alice Wallenberg Foundation is investing an impressive 300 million euros in material science for sustainability, an initiative called WISE, and you are the chairperson of this program. Could you tell us a bit about the ambition of this program, in particular also in a European context?
Absolutely. But first, thank you for the introduction, and thank you for inviting me. It's a great pleasure to join the conference, even though I'm on digital. I would prefer to be on site, but today it had to be digital. Yes, as you mentioned, we have started a strategic initiative called WISE, Wallenberg Initiative Material Science for Sustainability, in the area of material science for sustainability. So the theme of this session is highly relevant to our program. The WISE program is one of the strategic programs that we are running from the foundation, and it's actually one of the biggest ones. And when we run strategic initiatives, strategic programs, those are all national research programs focused on fundamental research, and we run them jointly with the Swedish universities. So in this case, the WISE program was started in 2022, and it will run until 2032. So it's a long-term program. The rationale behind starting these strategic initiatives is that we identify areas where we think it's very super important for Sweden to increase the competence, build knowledge in areas that we decide or deem are critical for Sweden and of course also for Europe to be long-term successful. And in this case, the area of material science for sustainability was a very clear one. Sustainability is, of course, something that is, I mean, the major challenge for all of us, the major issue for many companies, for industry. And material science, partly because the production of materials account for 25% of the emission of all greenhouse gases, but also because we think that the key to solving many of the challenges that we need to solve in the context of sustainability lies within the material science area. So as I said, these are national programs, so they are run on the major Swedish universities, together with Swedish universities, but also together with Swedish industry. So what we will do in concrete terms is that we are recruiting new researchers, professors, and assistant professors to Sweden. So in total 28 new recruitments, and each new recruitment is also with a package that includes 2 PhD students and 2 postdocs. We are also running an extensive graduate school where we will have 186 PhDs, and out of those at least 30 should be industrial PhDs. We are also working with postdocs, so 186 postdocs, and out of those at least 30 should be industrial postdocs. And we are supporting and funding technology platforms as well as research arenas together with Swedish industry. And the way a research arena works is that academia and industry, a company, join forces around the topic that is relevant both for the academic research but also for the research and the future of the company. And then the company, or companies, in many cases it's many, they contribute with technology, with knowledge, with platforms, and then open up for the academic researchers to do research on that platform in that arena. So the program is focused on 4 areas. The first one is energy. So it's about how we can harvest energy, transport, convert, store energy using new materials. The second one is around circularity, how we can close the loop from when we extract materials, we refine materials, we use them and reuse them, and also how we can avoid using rare materials. The third one is focused on the environment, so it's about cleaning and mitigation, both air, water, and soil. And the fourth is more dedicated to new things, new innovation that will come out of the program. As I said, this is a program that is focused on academic research, but it also includes support for innovation. And I think someone mentioned in the beginning that innovation in the area of material science is extremely live. So we will see lots of innovation coming up of this program as well. Thank you.
Great. Thank you so much, Sara, for this overview, which I'm also sure we will come back to. In particular, I'm curious how one can match this at a European level, this level of ambition. I would like now to invite Tom Erixon on stage. Tom Erixon is president and CEO of Alfa Laval, a company headquartered here in Lund. He has been CEO since 2016, and Alfa Laval is a global provider in the areas of heat transfer, separation, and fluid handling. Before joining Alfa Laval, Tom was the CEO of the steel and recycling company Ovako and worked for Sandvik and for Boston Consulting Group. His university education is in law from Lund University and an MBA from the Spanish IESE Business School. Welcome, Tom. And now maybe I turn the light on again so we can see you.
Maybe better not.
No, we want to see you.
All right.
And it would be nice to keep, okay. So if possible, it would be nice to see the Zoom picture as well, I believe. Yeah. Tom, my first question for you. You lead an international company with a very diverse portfolio, where I think even from the outside one can see that materials challenges must be important. They can be very specific and also urgent, I imagine. Your headquarters also happen to be neighbor with two of the largest European infrastructures for material science, one operational, one very soon. How can such infrastructures help a company like yours to achieve your aims?
Very much. But let me give you some context first with reference on some of the previous speakers. With the climate change in a company like ours, everything changed. And it's been like that for about the last 5 years or so, not more than that. And why is it different? I think the main difference compared to our 140 years history is that things need to go fast. And speed is a difficult matter in industry. And I'll outline a few aspects of that. When we have a good idea on a product, we think about that for a couple of years. And then some creative people come up with a few prototypes. And we start to test those for a little bit. And then we are 4 years in. Then we go on some sort of pilot testing. And that pilot testing, it can be rather long because we may produce stuff where people are going to throw billions of dollars in the years on the fact that it's going to last for 20 years. And as we're coming into climate-related issues, more often than not, temperatures are higher, pressures are higher, and the chemical environment is more difficult. So testing before you start to sell, preferably takes a couple of years. Then you build a pilot plant. The first customer signs up, takes a risk. So normally one signs up before all the other guys signs up. So they want to get that up and running first. That's a couple of years. And then we are 8 to 10 years forward, and that's when we go to market. And at that point in time, our capacity produced is 1, right? And 1 is not making a difference on climates. We need to sell 100. So the scaling needs to happen, right? And then we are 15 years down the road. So people who say we started too late, I agree. We are too late. The direction is right, but we started too late. But, the consequence of this situation is that we in industry needs to do things differently. We need to learn differently. We need to build knowledge differently. We need to be much more open source and collaborative with industry and with academia in terms of how we build and generate knowledge. And all the good nanotechnology we're talking about here will have absolutely no impact on climate unless we industrialize it quickly. And therefore, we cannot sit with material science for 5-10 years before we get it over to industry, who's going to take 10 years, because then we are 2050 already before we have a product, right? So for me, the question on how we operate and collaborate with the research, and here is special, and it's our good fortune. And we are a little bit ahead of other industrial companies, perhaps when it comes to Max 4 and so. But even for us, we are quite slow. And we need to address that question fundamentally to get something done. And I think, if you want another example of that, I happen to be the chairman of the Swedish Industrial Association as well. And we are changing presidents as we speak. It's been around for a long time, and every predecessor on that job has been a male industrial guy in 55 plus. And for the first time in our history, we have Pia Sandvik, who some of you know. She's the president of RISE, the big Swedish research foundation or institute. And that signifies the importance from industry that the R&D side and the innovation side, that's the problem we need to solve right now. So we're really happy about getting that profile in how industry will be seen and interact, but it's really a material change in priorities as to what do we need to do now.
Thank you so much. Very important starting points. Before we dive deeper into these questions, I would like to welcome up Heike Riel, our fourth panel member, and then we will be complete, please. Heike is an IBM fellow and department head of the Science and Technology Unit at IBM Research Europe. She is responsible for leading the research agenda of the Science and Technology Department, aiming to create scientific and technological breakthroughs, specifically in quantum computing, the physics of artificial intelligence, nanoscience and nanotechnology, precision diagnostics, and smart system integration, with a PhD from the University of Bayreuth in physics and a thesis on organic leads and an MBA from Henley Business School.
Thank you very much, Heiner, for the introduction and for having me here. Thank you.
So you work for IBM, which is one of the, 4 or 5 companies internationally with a very high profile in quantum computing. There's lots of challenges with realizing quantum computation, but one of them is certainly related to materials. Can you say a bit about that?
Yes, of course. So as I think probably in every technology, materials is also very, very crucial in quantum technology. And as you just indicated, quantum technology is a novel field, and it's a very active and dynamic field. We want to use the quantum physics to solve really difficult problems which classical computers cannot solve. And this can have different advantages. First, you can solve problems which classical computers cannot solve, but also you can hopefully save also energy for other problems. And thus also accelerate the research on materials as a consequence. So we will not replace classical computers. I think that's also very important to say. But there are many different implementations today. And so there are superconducting Josephson junctions for qubits, there are ions and atoms, there is photonic quantum computing, there is the use of spins. And you can imagine that in all of these fields, materials are very, very important. I always think a bit like the semiconductor industry when you go back in the late 60s and early 70s, when the first processors were made comprising 4,000 bits or 4,000 transistors. So we wouldn't have believed that we can build technologies like processors with 50 billion of transistors, where each and every one is the same, where the gate length is 10 nanometer. There are materials down to the nanometer scale precision on 300 millimeter processed. And so I think today we are in quantum computing as in the late 60s, early 70s, and you can imagine what materials innovation, what materials research can help to advance the technology, to advance the performance, that with these new quantum computers we can do then in the future things we would have not believed to be doing today. So I think there is really a very, very high potential in these areas. And I can mention a few. If you go to superconducting Josephson junctions, you have today materials like aluminium, aluminium oxide, aluminium, this junction, or niobium. There may be other designs, there may be other materials we can use. The purity of the materials, the fabrication, processing of the entire device, all influences, for example, the coherence time. And this again influences then a lot the performance. So improving the qubit quality is really very important. This also includes new types of gates, reducing the losses, and a lot is the design of the device, but also a lot the materials. If you want to scale the things up to many thousands of qubits, and today we actually have a processor of 433 qubits, which is already a lot. And at the end of this year, we want to demonstrate more than 1,000 qubits. But materials are really a challenge for the packaging, for example. You can no longer combine these qubits in plane. You need to make 3-dimensional packages, which have to not only work at room temperature, but you have to cool them down to millikelvin and heat them up. So again, a materials challenge and a combination of materials challenge. If you look at spins, silicon or germanium spin qubits, then you would like to have isotopically purified materials to reach the quality you need to have. So in each of these technologies, the same for atoms, the same for photonics. There are new types of materials, improvements needed, which go beyond what we can do today with semiconductors. And so to fulfill the promise of quantum computing for the performance increase, for lowering the energy consumption of difficult problems, and thus be able to accelerate actually materials innovation, because we hope to use quantum computers for exact simulation of materials and thus not do a lot of experiments, but accelerate the process that you can have the material we all talked about before already. And so this is what we hope to achieve, and materials are important.
Wonderful, thank you so much. So welcome to all 4 panel members then. And I would like to pick up on the theme of speed. So we heard this in the introductory notes, we need to act now. I must say I was a bit shocked is maybe not, is too strong, but close to that, even from the industry side. My perspective from academia is typically we are too slow. We would like to be faster, to go from research to implementation. To hear that this, and we always like to think that in industry things are much faster. So also you think things are too slow in industry. So I would like to have your views on what can be done to speed things up. And maybe both, Tom, maybe if you could expand on this a little bit, but also I would be very interested to hear from Sara, because I think we have the same, very much the same question. If you fund basic research and want to see impact in a very short time, how does one do that? So can anything be done to speed things up?
Let me start with the reflection since we talk about computing.
Yeah.
Currently about 10% of the global energy consumption goes to data centers. Not too far away, and you can think about AI and all of that, it may hit 20, right, of the global energy production. Where does that energy go? It goes into waste heat. It's essentially 2% that goes to computing, and in reality it's generating heat. So if I would look to material science somewhere and making a difference, I would suggest finding a way to cut, because this is going crazy. We are now working on water cooling solutions in Alfa Laval because the heat generation in large-scale computing is now so high that you can't cool it with air any longer. And so if we look at areas where we need useful progress, that's a very clear example of that. In terms of what we can do, I think Daya was on to something that in the Swedish perspective is very important. We need to, I'm not much of a favor for throwing money on private business as such. Subsidies are sometimes needed, startups sometimes needed, but I think in the industry we are quite capable to create the business cases for the solutions that are needed. But the research programs, they need to be long-term secured and funded. And we cannot do all of that in industry alone. So I think clear EU and national research policies with clear long-term funding needs are going to be there. And I think from the discussion we have in Sweden right now, where we are, if anything, looking at downgrading those programs a little bit, I think that would be a big mistake. If I look back over the last 10 years, the research programs that Sweden has funded has been super well aligned with industry, and I think with academia to a degree as well. And I would say to keep those going is a very clear priority.
Water cooling came up when we started actually in Zurich to work on water cooling in 2003, because we realized that you can no longer cool the increasing of the power consumption with just normal fans, in particular for servers, right? Yeah. And in 2003 we started, and in 2010 we had a concept to cool the big plates for the HPC, for the data centers, for the high-performance computers. And we implemented this with the Leibniz Rechenzentrum in Munich. We called it hot water cooling because you actually use the water to cool the chips. You get out about 50 degrees of water, and you can heat all your environment with it, right? And this was implemented, and we saved 40% of the energy consumption of the Leibniz Rechenzentrum in Munich. But the problem was that at that time, the energy was too cheap that people used the system. So it's actually not only a technology problem, it's often also a political problem or an economic problem that these technologies which are available are then implemented or further used. And so we actually had this technology, we implemented in a few others, but even to today, it's not really picked up. And so it's a question of typically companies, right? They say, okay, what is my cost? What do I need to pay for it? What is my gain? And so then they decide. And I think we have a good example here in front of us, solar cells, right? You pushed solar cells for many, many years in Germany and around the world. And only today they become so cheap. Actually, we calculated last week, if you buy such a balcony panel, right? If you plug it in, it's not even 2 cents what the kilowatt hour is. So now people start buying it. And the same is true, I think, for hot water cooling in HPCs. If the energy bill is so high that it's worth implementing, then people do.
Great. So we have alternative computing technologies. We have implementation to actually make that happen, to take away hinders. We can maybe get back to that. We also have long-term research funding as a long-term stability there. Sara, would you like to add something to this?
Yes. First of all, Tom, thank you for talking about long-term funding. That is exactly what we do, and that is why we think it's so important that our funding is long-term, because that is needed to make a change. The scope of sustainable data centers and materials for sustainable data centers is definitely within the scope of the program. So maybe we will see some really interesting research projects in connection to data centers. But coming back to your original question about how we can speed up, I think there are a few things that we can do. We are working on them, but I think we can become even better. And one is to work even closer between industry and academia. So as I said, in the program, we have industrial partners. This program is fairly new, but if you compare with the sister program, VASP, Wallenberg AI Autonomous Systems and Software Program, we have over 80 companies that are partners in the program. And I think that is one way to speed up the transition of research and research findings from academic research into the companies, is to have this very close collaboration where we actually have an overlap between what is done at universities and what is done in the companies. Another thing that we can, I think we can do better is to think about how we can spur collaboration between startups and established companies. Because in the area of material science, we see a lot of startups coming up with new technology. And how can we speed up the collaboration between those new companies and the existing companies that really need to use the new technologies that come out of the newly started companies? So at least two things on my mind: collaboration between academic fundamental research and industry, and also how we can spur collaboration between big and small companies.
Great, thank you. I forgot to say...
If I may, maybe
yes.
Something about the speed element, because I think it's really important, given that we have the deadlines that I mentioned earlier. 2030 is round the corner, and we have the 55% greenhouse gas reduction target and 2050 on climate neutrality. Certainly, usually we're talking about a 10-year period, aren't we? From research to product. But in this context, I see three elements are essential. Firstly, I think the material science has to make a deep dive into how to accelerate. That's number one. Number two, I think industry has to be ready to work with researchers and universities in terms of priority setting and also backflow on blue sky research issues, which is, if I may, not happening enough. And thirdly, materials should be traceable also in future products in terms of their environmental footprint, and also allow for reuse and recycling and the circular economy. I think just to string everything together, maybe we can simply say we simply cannot afford to work in silos anymore.
Okay, thank you. I forgot to say that I welcome also questions from the audience. So if you would like to say something, please raise your hand. I will try to keep mental track of you and come back to you. The same is also true. We have people listening on the stream, and it's possible to post question in this online format. And for Sara and Joanna, please do what you just did to speak up, or you can also raise your digital hand, and I hopefully will see it as well. Yeah.
I wanted to add something also on the acceleration and speed, because I think when we look back like 4 years, we have a good example of how the world actually worked together on solving one problem. It was COVID-19. And I think here perhaps we can learn from what we did to accelerate and solve problems. And I think one thing I see also coming from doing research in a company is that sometimes you have to pick the problem and solve it and not the technology you want to develop. And I think that's a very specific difference in goal you have. Because if you want to develop a technology, you keep going on developing the technology, but you not necessarily solve a problem. And I think we really, and this is also true for how funding is done, right? So if we want to solve a problem, as we obviously want to do and speed this up, we have to fund also much more problem-oriented and bring also teams together who work on the problem and use the technologies which are there and give feedback to how these technologies and long-term projects should continue. So I think it's really a need for, on one hand, long-term funding, which has been set for developing and continue the foundational and the understanding and to provide kind of input. But on the other hand, I have also funding which can be more short-term, more agile, and are solution-driven.
Right, and to be able to switch technology depending on where to
Yes,
go.
because it's not about the technology, it's about the problem to be solved.
Tom.
I think that's a very good point. And to make an example of that, at Alfa Laval, because we're neighbors, we've been involved in the Max 4 project for some time and trying to support it in various ways. I think Max 4 is an excellent example where there is a technology available, or platform, or a research method, which is fantastic. And it's very easy to fund a new beamline. You know, it's easy to throw 10 million SEK, 20 million, 50 million on building the platform better. The amount of money that is spent on defining a problem that we want to solve from industry and how we use the instrument is very limited. And that's exactly the bridge that we are trying to work on, not specifically for Alfa Laval's metallurgical problem, but to connect the instrument and utilization of it with funding and direction on fairly generic industrial problems that we are trying to solve across many companies. And this is, I think, a typical example of what you are describing. We need to take that second step and not make Max 4 just better, but actually applying it to the real problems we're trying to solve.
Thank you.
If I may add to this, sorry about that, Heiner. But I think it's really important also for that the researchers at universities, sometimes you miss what is relevant in the industry or what is needed. And I think this discussion and platform for those discussions to have, that we can have a good collaboration and know what is needed. Sometimes these things are there, but they're just not used, right?
I would like to get back to the question of take-up. You just said it, one needs to know about it, but sometimes I think it's also simply inertia in the system. It's easier to keep a production line going as long as it spits out what you want to use, and regulation and so on. So what role can strategic frameworks like the Green Deal, what is their importance for example, for actually building momentum for new technology, but then also for the take-up? Anyone who would like to comment? So for example, is it setting aims, saying in 2050 we need to achieve A, B, C, and D, or ideally earlier, 2030? What role does that play for industrial strategy? Let me put it like that.
Yeah, I can give one starting comment on it. It's a broad question. I think from an industry point of view, one of the fundamentals is that we believe that there is a long-term commitment to something. So that if there isn't a path for the next, and people think we are quarterly capitalists sometimes. We're not. We work with 10-year plans, 20 years plan, and in the climate thing, we're working towards 2050. So we need to know, do we want hydrogen or not? Do we want biofuels or not? Do we want, where do we want to go on this? And so I think the Green Deal, and to some respect IRA, has created some sense of certainty in purpose and direction. And I think that's a good thing, and that's needed. I think there are two other things from the EU that are exceptionally important for industry. The first one is, and I know I'm not the spokesman for everybody on this, but I believe we need high energy prices. I think price mechanism is what is driving behavior for consumers as well as industry. And this panic we had about the increase of energy prices was partly warranted, it was partly exceptional, but directionally speaking, I think pricing is the best mechanism for the market economy to work. So before we subsidize too much on being competitive on low energy prices, I think we should take time. You like, he's from E.ON, he's selling energy. Now, the other thing that I truly like is the transparency in the reporting. You know, in the moment when we report and follow, you know, on scope 1, 2, and 3, we will get a much better understanding for the value chains and how we make decisions. And those two EU-initiated policies are super important long-term drivers of what we're going to do. I think we cloud ourselves with too much small stuff in subsidies, in specific regulations that sometimes works for and sometimes against what we try to do. But these fundamentals and long-term stability, I'm fully supportive of.
Great, thank you. And Joanna also has a comment.
Well, if we are going to provide a focus, which I think the Green Deal has provided a focus, and the set of initiatives I mentioned earlier, you know, and the targets that we have put ourselves is providing the focus on the problem, which was what was referred to before. The next step is to concentrate on which technologies will get us there the fastest, and which are those that can be scaled up the fastest. But in doing that, not only do we have to identify the technological sovereignty, if you like, but we also have to ensure that we are actually identifying and putting all our efforts at European, at national level, to actually make it happen easier on the ground. In other words, also to avoid overlaps in order to ensure that there is technological sovereignty and also lead to more European strategic autonomy, which I think is also what we're looking for strategically. And this is why, for instance, we have set up huge initiatives, large-scale initiatives that, for instance, like the quantum, like semiconductors, like the battery, like hydrogen, where we encourage a very clear delineation of these technologies in order to achieve synergies as much as possible. And one goal for advanced materials to pave the way for the engagement of all the stakeholders is and co-create a European materials ecosystem is exactly what we are looking at here. And I believe that Peter Droll will be talking about this a little bit more, a little bit more in detail and expand on this, because I think we need, subsidies, energy prices have been mentioned, but I think we need interventionism, if you like, to a limited extent, of course, in this way, in order to have a very coordinated plan, focused plan to solve the problem and to get to the targets that we want to get to.
Great, thank you. Heike.
Yeah, I can add from my experience within IBM and from the research aspect. I mean, for many, many years, we have like a corporate strategy to save energy. And every year we committed ourselves, I think since 20 years already, to solve energy on a yearly basis. And it came at a certain point, you have to switch off hoods, right? So actually it starts sometimes very simple, that you think about where you consume energy and whether you still need to consume that energy or you just can do some savings. When you have done all these little pieces, then at a certain point then it really sometimes gets painful, right? But I think having this in your corporate strategy has become, with the Green Deal now, also more awareness, more visibility. And now it's even going more into the core of the research, because now in all our research programs, we think about and implement sustainability. We implement also the, how to save energy, how to produce energy, and how to store energy. So, because now it's also important for the consumer, because the consumer is aware, and the consumer also wants to have products which are sustainable, which are part of the recyclable, etc., etc. And this becomes very important, because this now actually hits also back the companies. If you are not having a product which is not sustainable, then people will not buy it. And so now, and these mechanisms, as you and me before indicated, you have to have mechanism where you force the institutions and even yourself to save energy. And I think this is now coming, but we are also probably too slow in implementing these type of things.
Great, thank you. I'll let in Sara first, and then there will be a question from the audience. Sara, please.
Thank you. I just wanted to reflect a bit on the role of European programs and our national programs. So the research that we are funding is limited to Swedish universities, and that is by our statutes as a foundation. So we are limited to operations in Sweden. But there are very good examples where our programs have fit very nicely into the European programs. And one of those areas is the quantum area, where we have the Wallenberg Center for Quantum Technology centered around Chalmers, and that is the main connection to the European quantum program. So I think could be a very nice fit between our strategic programs in Sweden and also how they could make a bigger impact and also contribute on the European level.
Okay, thank you. And here's a question from the audience.
Thank you very much indeed. My name's Robert Harrison. I'm an intellectual property lawyer. I've also got a PhD in photonics and working in a couple of EU programs, as well as being an angel investor. And with respect to Joanna Drake, I'd like to take issue with the point that she made, which is about focusing on certain technologies. And I think that Heike Riel made an excellent point when she said that we should be focusing on the problems and then looking at the technologies that could actually solve those problems. Because I think there's a real danger, particularly on some of the EU programs, that there's just been so much focus on certain particular technologies that we may be losing the opportunities to think about out of the box, look at absolutely novel technologies. As the United States, for example, through its DARPA research programs, has done quite successfully in several areas. The second point I'd like to make, if you'll allow me, is that I think we need to be a lot more certainty about long-term research funding. And I'm particularly pleased that, for example, that the graphene flagship and the quantum flagships have actually been successfully going on beyond the originally, 7 years lifetime program. Because I think that's very important in deep tech, in material science investment, that we realize we're not going to get the returns that we may be getting in digital science, digital technologies, and that the Commission and the funding agencies really need to have this long-term vision in the future. Thank you.
Anybody would like to reflect on this? So agility is an important theme again. Yeah, maybe then I can fill in with a question and switch topic a little bit. The European Union, so we have talked about solving climate challenges mostly. We are also, with initiatives such as the CHIP Act, there's also a very clear global issue or global aspect of funding, namely that the EU in some aspects also competes with other parts of the world, most notably USA and China. So we have global issues to solve. There's also competition aspects. How do we position the EU in such a global competition? So one aspect is exactly competition versus collaboration is an important question for me. It's also about how do we collaborate best? How do we avoid that we internally compete and rather build the best possible team EU? Is there anybody who would like to comment on this? Joanna.
Maybe I could start, yes. But I'd like to pass a comment first, if I may, on what Robert Harris has just said. Well, I would take issue with his assumption that the European Union is not looking at all the alternative kinds of technologies. And that could possibly solve the matters. I think we are very much focused on not only solving the problem, which is what has been suggested earlier, but also getting to the targets and ensuring that there is an ecosystem in place that is actually aligned with achieving those targets, but without keeping away what other technologies which could be actually being addressed through blue sky research, but also other types of partnerships and initiatives, including with the private sector, in order to make what works happen and scale it up ASAP. I would accept that we might not have the ecosystem as fast as it is in the US, which is what you have mentioned before in terms of scaling up, and maybe this is where we need to notch up our efforts, our coordinated efforts. But I would say that we do not definitely consciously leave out alternative technologies that might actually be important for the pipeline of success, if you like. Regarding your question about competition and cooperation, of course, these are very important concepts that resonate very importantly in the international arena, I would say, most of all. And here I think the European project is very strong, and it has areas where itself can actually use its presence on the international stage to showcase a very strong and leading role, including in the areas of nanotechnology and advanced materials. And I believe that we still have untapped potential here to coordinate and also optimize the available resources. And this is where we are aiming our initiatives, to ensure that we have the skills, that we have the excellence in order to boost our resilience, and also to provide regulatory clarity, which is really important, especially for the markets, but most importantly also on the international stage. But I would say also to signal and steer financial support. We can already build on the wealth of excellent cooperative research actions, especially when it comes to basic and lower TRL level research. But of course, we are facing the reality of energy, material and product dependencies, and our main partners are also, in fact, our competitors. And therefore, what do we do in this scenario? We have to keep a clear and an open dialogue where we forge the understanding of our strategic relationship. And this is absolutely necessary. And what is important, I think, here, and definitely a necessary precondition for safeguarding our position on the international scene, is a strong cooperation with the European Union. And this will allow us, together with the member states, to speak with our partners and competitors with one strong voice. And I think this is something definitely that needs to be very robust and very clear.
Thank you very much. Sara also has a comment.
Yes, I'm thinking about the collaboration and then how we can ensure that we also can be competitive. And in my mind, there are two things that are super important for Europe to be long-term competitive, and those are talent and innovation. So I would say that we are fairly good at fundamental research in Europe. We have a good position, high quality research, but we lose a lot of talent to US. And I think we should ensure that we are attractive enough so that we keep the talent in Europe that we actually build in Europe, and also that we can attract talent from our competing other areas such as the US. And when it comes to innovation, we are very innovative, we're very good at starting companies, but in many cases we lose them when they grow a bit. So that's also an area where I think we can do much better in Europe to ensure that we can build sustainable European companies out of the innovation that actually comes from Europe. Today, I think we're handing out too much talent, too much competence, and too much innovation to other areas.
Great. So cooperation, ensuring that we are attractive to talent internationally, globally, and ensuring that our startup companies like to stay here. We are waiting for one question in the back, but this seems to be an immediate response. So
yes, thank you so much for the introduction. I don't want to talk about solar energy because I have a presentation later on, but I want to make a very different kind of suggestion. Germany has a very high competitiveness in industry, and people might ask, why can this small country do so relatively well in industry, production, and so on? And one of the solutions to this question is Germany has a system of Fraunhofer institutes. 70 institutes, 25,000 scientists working exactly on the topic transforming innovation into real technology, solving problems, working with small companies who have a technology problem to solve this problem. What I never understand is, why don't we form a European Fraunhofer-type institutional networks where really those institutes are not gearing for the latest blue sky type of research, but who measure their success from interaction with industry. Fraunhofer institutes are charged to have 1/3 of their budget from industry finance projects. And I tell you, Fraunhofer institutes never need an evaluation, because to be able to secure 1/3 of your budget from industry projects, you have to be the best in technology and you have to go out to work with industry. Of course, the German Fraunhofer have no interest to say, we want to expand Europe-wide, because why to create competition? But if I think about the bigger picture of Europe, that would be a very, very interesting way to think about it.
Great. Thank you. So a fourth suggestion to form an institute network. But we are waiting for one question in the back. You have a microphone already. Please
yes, thank you. Good morning. Steffi Friedrichs. I work for a very small consultancy based in Brussels, ecumenist, mainly based on innovation, science and technology. So I identify a lot with everything that was said this morning in the opening and specifically on this panel, because that is what most of my job is about. But I feel challenged to ask a question that, and do shut me up if you believe it doesn't belong into the setting at all, which comes out of the context and content a little bit that we are doing here. We are hosted by a university. We have, however, spent most of and there were many people whose job is actually in leading universities, directing universities. But everything that I've heard so far sounds like our problems can really only, or really ought to be solved only by looking at everything that happens from being a fully baked researcher onwards. We have said very little about what role university education in educating the people that do all this work that we just identified would have to play. Maybe the answer is that there is no need to change anything in the education of researchers, innovators, and the way that they're working together. Or maybe there's a lot to be said about that, and we are actually meant to come on to that later. But I do miss it a little bit, considering that the brain power of people who have both an educational vocation here in this room and an educational responsibility, and the people who are obviously innovators and are trying to solve the technological questions of the world.
Yeah, I believe that's a very important question, and it's indeed true we haven't talked too much about competence development here. Speaking for academia, I'm the one representative here. This is certainly very high on the agenda, and I think you make a very important point also, that with the transition to switching the car industry from combustion engines to electric, switching to quantum, there's a huge need to educate also those who are in work life already, I believe. Sara has her hand up. Would you like to comment? And then Heike. Yeah.
Yes, I think that was a very good point, the importance of education. And maybe I went a little bit too quickly through it in my introduction, but that is actually the main reason for starting the strategic initiatives that we have, to build competence. And when I talk about competence, it's not only research results, but I talk about people. So altogether in our strategic initiatives, we will educate over 1,300 PhDs. And we also very closely keep track on that the strategic initiatives do not only work on PhD level, but also that we are developing courses on master level and below, because that is where we will build the main bulk of competence that is needed to be long-term successful. And we are also funding initiatives for building courses in the strategic areas on basic level, because education is super important. So very good point.
And Heike also had a comment.
I think that's a very good point, but it's not only true for universities, because this is actually a big problem in companies. Because if you look at the German car industry, that's been mentioned before, that's one of the biggest problems of all the big car companies right now, that they have people who build a motor, but they would need people who write software. right? And this is a big transition to make. And there are many different, so we go through these things also. I had, for example, also training people who came from semiconductors to AI and to learn and to do semiconductors and do software writing or circuit design and other things. And a very important thing is that this is not only the duty of the university. It starts by each individual to be willing to continuously learn, because the information is today available. You can just go in the internet and you find a lot of information to learn. And I think we need to, as a society, encourage really everyone in our society to be very proactive and to keep your own value high and not rely on someone else to give you a course. Because in the end, you need to learn and you need to have the willingness to learn. And this, I think it's a societal problem. It's not only a university problem to encourage, starting with your kids, that you learn, continuously learn until you die. I wanted to say retire, but it's really until you die.
Right. Now there's lots of hands. Unfortunately, we will run out of time, but there's one very short question.
Very short question. Alina Dulimov is my name. I am a physicist, graduated with distinction. I worked for Erixon at the beginning of my career, and I'm very thankful for that. I noticed that people with money decide more, so I moved into investments, and now I'm coming back to the industry, technology, and research. And I have one question about manufacturing. IMEC, for example, it's one of the most advanced research centers, and they are still reliable on chips produced elsewhere. What do we think about the sustainability of the manufacturing/mass production processes? Number one. And I would like to coin one term here, because I think it's a great form for that.
I think
it's misallocation of talent while talking. There are too many people thinking of the design and not on the manufacturing processes. So any opinions and any thoughts about the manufacturing, mass production of the technologies we innovate and research?
Thank you. Tom looks
that was an easy question to round off with. I'm not sure I'm answering, but I'll share some reflections. I'm a little bit concerned about driving the strategic independence thinking to, the ones of us who grown up in the industry, we are globalists by nature, and we have thousands of people in China and R&D and in US, and it's really hard for us to come to some sort of geography by geography. And that's the reason why I think EU's strategic independence strategy need to be more focused on competitiveness in Europe and ability to flex from to. German automotive industry is just one, but we have this exactly in our own companies as well. Speaking about manufacturing, we are starting to move to collaborative robots for the first time. It may not seem from an academic point of view as a big thing, but it means we have thousands of people who never interacted and worked with robots before. And if I may point towards a solution for Europe on this issue, in Swedish labor regulations last year, we were responsible together with the unions to work out a lifelong training type of program. It as omställningsprogrammet, which basically meant that the union traded a bit of labor security in existing position, existing company, but against a commitment from government and from business to actually allow people to go to 1-year training courses paid. And many people thought that the industry didn't, was something that we gave up. But for us, with thousands of people, we don't want to fire everybody who is 45 and recruit 25-year-old who knows how a collaborative robot works. So this whole, I think there's a lot that happens on the production side right now. I'm not sure that local production is going to be, and small scale is going to be the solution for the future. I don't think so, but I think there's a lot that's going to happen in the processing, and the competence demands for our future workers as well as our engineers is going to be very, very different. And we need that training and process needs to be facilitated.
Great, thank you very much. We are out of time, so I would like to ask the 4 panel members to just in one word What do you think is the most important thing going forward? What is your takeaway? And I maybe start in reverse order this time. Heike, would you like to start?
So I use 2 words, focus and collaboration.
Thank you. Tom?
Faster.
Thank you. Sara?
Collaboration.
And Joanna?
I would use 3 words, if I may, European cooperation, acceleration, and also innovation and research.
So certainly a collaboration and speed high on the list. Thank you very much. Please a warm hand to our 4 panelists.